Good day everyone, I am Yauhan Makoto and today I'll be presenting my Packet Tracer network simulation. For this activity, I created a simple but functional network setup that allows multiple computers to connect and communicate with a central server through a single router. So in this project, I used 3 PCs, 2 switches, 1 router, and 1 server. The goal is to configure all necessary network parameters, enable connectivity between devices, set up a working HTTP web page in the server, and configure DNS so that users can access the server using a domain name instead of an IP address. So here's my topology. I have two networks or subnets connected to a single router. The first subnet, which I call the student network, contains the PC 0 connected to switch 0, which is linked to the router's interface, which gigabit Ethernet 0/0. So the second subnet, which I call the server network, includes PC1 and PC2, and server also connected to switch, which is linked to router 0 gigabit Ethernet 0/1 of the router. So this setup demonstrates how routers can connect to different networks and allow them to communicate with each other even if their IP addresses are from different subnets. So for the IP addressing, I use two separate networks. For the first network is 192.168.10.0/24, which is assigned to the student side. The second network is 192.168.20.0/24, which is assigned to the server side. So here are the specific IP configuration I use. So for the PC0, I used 192.168.10.5, and then the subnet mask is 255.255.255.0, and then this is the default gateway, and then I will explain this later. And then sa PC1 is I used 192.168.20.10, and then here's the subnet mask, and then the gateway. And then sa PC2, I use 192.168.20.11, and then here's the subnet mask, and then here's the gateway. So sa in router gigabit Ethernet 0/0, I used 192.168.10.1, and then the subnet mask, and then the Gigabyte Ethernet 0/1, I used 192.168.20.1, and then here's the subnet mask. So, so for the server, I used 192.168.20.5, and then the subnet mask, and then the gateway. So all devices use the same DNS server IP, which is also the server's IP address. So we will put 192.168.20.5 here in the DNS server, which I also put on PC0 here, PC0 and PC1 and PC2. So after assigning all IPs, I went to the router's command line interface, and then I enable each interface and assign the IP address. I use these commands, this one, and then after that, I verified it using show IP address brief. Both interfaces showed up app/app, meaning the router is now actively forwarding packets between the two networks. Since both networks are directly connected, I didn't need to use any dynamic routing protocol. So next is I configure the server. So under the desktop tab, um, I assigned its IP address, the subnet mask, the gateway, and the DNS, as I mentioned earlier. Then I went to the service tab. Tapos, first turn on the DNS. So I turned on the DNS. I set my name to yhnmm.com. And then I put an IP address which is 192.168.20.5, the DNS IP address. So this allows any device to reach the server by typing yhnmm.com instead of memorizing the IP address. So, and then I forgot. HTTP, I turn on the HTTP, and then edit the index.html into this, like this. Welcome to yhnm.com. Hello, welcome to yhnm website. And then this is our server webpage for packet tracer simulation, and then I save it. So this confirms that the web service is active and accessible. Once all devices are configured, I started testing the connectivity. First, I tested the router's connection from each PC using the command prompt. From PC0, I ping, I type ping 192.168.10.1. So it replied. And then we will also try um, the we will also try to reach the server being 192.168.20.5. Let's wait for a moment. So it's and and it also worked, providing the routing between subnets is functioning. So next, from PC1 and PC2, I ping both the gateway 192.168.20.20.1 and the server 192.168.20.5, and both responded correctly. So you can see that it replied. And then next, finally, I tested the DNS and HTTP function. So I opened the web browser on PC1, and then we will type the YHNMM. Let's wait for a minute. Okay. HTTP. Wait. YHNMM.com. So the server web page appeared, showing that both DNS resolution and HTTP hosting are working properly. This means that entire network setup is successful and functional. So let's try in PC2. HTTP YHNMM.com. Oh, it also showed up. Let's try and play C0. So let's try HTTP. See, we can. also shows the website. So to summarize, I was able to configure all devices with with the correct IP address and gateways. And then enable router interfaces to forward packets between two different subnets. Set up a DNS server to resolve domain names to IP addresses. Configure an HTTP server to host a simple web page. Successfully verify network connectivity and DNS resolution using ping and web browser tests. So this project demonstrates how routers, switches, and servers work together to create a functional network environment. It also shows the importance of correct IP planning, gateway assignment, and proper configuration of network services like DNS and HTTP. So that's all. Thank you for watching my presentation. This includes my packet tracer simulation showing how I configure a basic 2 network setup with routing, DNS, and web services. I hope you learned something from this demo. Thank you.